AP Calc, AB, Unit 6, Day 10, warm up. So try the problems yourself. We're taking graphs of derivatives and then trying to sketch. Now there's this extra piece of information. So instead of the plus C value, that's telling you where you're going to actually start your graph. It's called initial condition. So try all of these problems and then so pause the video and try all these problems, and then I will go ahead and show you guys how to do it. So this is the starting point, by the way. Okay. All right. Assuming you guys have tried these, we can, we could start our graphs at 0, 3 instead of doing the plus C thing. I would label this graph first. This is where f prime is positive, increasing, f prime is negative, decreasing, f prime is positive, increasing, f prime is negative, decreasing. These are critical points, which I don't usually think of those when I'm graphing these. Concavity is the slope of is the derivative of the first derivative, which we have a graph of, so the slope of this graph is the second derivative. F double prime is negative, concave down, f double prime is positive, concave up, f double prime is negative, concave down, where it switches concavity. Those are inflection points. So we have lots of good information here. So I would try and, I like to extend these just to make it a little easier to see where I'm trying to get to. So the first one is increasing but concave down. So I usually do almost like little quarter circles. This one's decreasing and concave down. This one's decreasing but concave up. This one's increasing and concave up. This one's increasing and concave down. This one's decreasing and concave down. So there you go. Just rough sketch. Okay, next one. F prime is negative, decreasing. F prime is positive, increasing. F prime is positive, increasing the whole rest of the way. So the graph goes down a little bit and then it goes up the whole rest of the way. Concavity, f double prime is positive, concave up. F double prime is negative, concave down. F double prime is positive, concave up. And for here, f double prime equals 0. So it has no concavity. What kind of graph has no curve to it? Straight line. So got some good stuff here. So we're going to start at 0, 3. So plus C. So the first chunk is going up. No, first chunk is going down, but concave up. So something like that. Next chunk is going up and concave up. Next chunk is going up, but concave down. Next chunk is going up and concave up. And then here, the slope has a 1, value of 1, by the way, over here. So the remainder slope is 1, 1, 1, 1. So the slope of this graph should look like it's a slope of 1 the rest of the way. And it should probably be it should be a smooth transition. So no corner, smooth. Okay. This should be a straight line with a slope of 1. So there you go. Interesting. Okay, next one. We're given equations of a graph, and we're trying to find these points. This is the domain of the function. Okay. But also this is the domain of this function anyways. X has to be greater than 0. So you keep that in mind for your final answers. Now I'm going to kind of ignore that while I'm doing the problem. Find all critical points. Y prime equals 0 undefined. Back in chapter 1, when we were solving rational equations, we said, you know what? We should make them into a single fraction. 2x minus 1 over x. Do not cross multiply. So undefined comes from the denominator equals 0, and the 0 comes from the top, positive 1/2. So those are your critical points. So your critical points. Now, here's the deal. We're not going to actually include 0 because it's not in the domain. So not in the domain. Now, I'm going to include it on my work, on my next step. But as far as like an official answer, critical point's only at 1/2. Okay. B, where is it increasing? Well, we have our critical points. So I'm going to do a line check. And I'm going to put 0 on there because it could still have an effect. If I tested the value over here, it would work and give us the right answers as long as I had 0 there. If I didn't, mess it up. So I'm going to leave any points that are not in the domain in my work still on my line test and stuff. I'm going to test 1, which is going to be positive, negative, positive, increasing, decreasing, increasing, relative min, relative max. But for answers, I'm not going to consider that. But I'm going to put it in my work. I'm just not going to consider it. So my final answer is that is increasing on the interval 1/2 to positive infinity. We include the endpoints on increasing, decreasing if they're in the domain of the problem. Okay, C, where on what intervals is f concave up? So we need second derivative. So we could work with the original problem, the original y prime in fact, I would do it like this. Because then the derivative of that is going to be positive x to negative 2. Boom, 1 over x squared. Or you could do quotient rule with that, but that's going to be a lot harder. So equal to 0 undefined. You should get the same answer if you do quotient rule. So x equals 0, and it's a double, but it's outside the domain, but I'm still going to put it on my line check. 0 star, test a value, x equals 1. It's positive, stays positive, concave up, concave up. If they asked you where's a concave up, you wouldn't even say the whole thing anyways, by the way. You would have to break it up at 0 no matter what. So if we were just doing this, this is what your answer would be, ignoring the domain. But because of the domain, we're only going to give that answer. That's when it's concave up. So, all right, keep an eye out for domain. So even if they didn't tell you the domain of the original problem, you should have caught it because that's the domain of those functions. That's it for the warm-up.